Hello, everyone, and thank you for attending today's webinar, Hyper-Convergence, Avoiding Hypervisor and Hardware Lock-In. My name is Scott Delo. I'm a vExpert, and I'm the co-founder of Actual Tech Media. I'm joined today by Arjun Narang. He is a technical marketing engineer for Maxta. Arjun, thank you for being here today.
Thanks for having me, Scott.
Before we get started on today's webinar, I would like to make sure everyone is aware of the Q&A window that we have in the GoToWebinar control panel. If you have questions, we encourage you to ask them in that Q&A panel. We do have plenty of time for questions, and we want to make sure you get as much information as you possibly can out of today's content. We'll also be picking a prize winner at the end of the event, so make sure you stay on till the bitter end so you can actually see if you win the prize. And again, please use the Q&A control panel liberally, because we really do like to answer questions as a part of these events. We find you get much more value out of them. So what are some of the business benefits of hyperconvergence? Well, first, we get a streamlined, really deployment process when it comes to our infrastructure. And that's one of the things that really can't be overestimated. We've really taken a sort of chunked approach to our infrastructure in recent years, and it's added a lot of complexity to what's already a complex environment. By being able to streamline things, we can actually deploy more consistently and in a way that's more budget-friendly and process-friendly. And that helps us to simplify our overall IT operations. And that's one of the key things that I talk about a lot as I'm talking to people around the country when I do speaking engagements. It's about simplification. And that's one of the things that people are really trying to do, is they don't want the data center to be a complex place anymore. In fact, one of the questions, or one of the jokes I ask the audience is basically, does anybody actually on their way to work in the morning say, how can I go make my job harder? And that's generally, a question that people don't want to have answers to, because we're trying to make things easier. When we start talking about hyperconverged infrastructure, one of the key things that people start to think about is the fact that we can basically eliminate the legacy storage environment. There's no more overall complex storage environment to manage. We actually sort of consume the storage as a part of the hyperconverged infrastructure, and it gets put into the compute layer and managed along with compute in a way that makes it much easier to manage and much more cost effective. When it comes to scale, we don't have to think about, are we going to add more capacity to our SAN, or what are we going to do? Things just scale more easily. Now, with certain solutions, scale happens a little bit differently. With some solutions, we simply add an appliance and we scale everything linearly. We add more RAM, more compute, more networking at the same time. With other solutions, we can do that, or we can actually add more individual resources to each node. And we're going to talk about that a little bit more in depth in just a few minutes. So basically, there's scale by adding blocks, and then we have software that glues it all together. And that's the power of the hyperconverged solution, is the software. And it brings together this commodity hardware in a way that we really weren't able to support in the past. And it makes things a lot easier for IT to manage. We can also start to think about significant performance improvements. If you think about our storage environments in particular, we tend to have a lot of storage challenges in those environments when it comes to performance. And part of the reason for that is we sometimes are using the storage in ways that was never intended to be used. We've seen this a lot with the failure of some first-generation VDI projects where storage was sort of overlooked as a critical resource. And when we start to think about hyperconverged scenarios, we have a combination, in many cases, of flash and spinning disk, so we can start to overcome some of those performance improvements without having to add complexity to the environment of having to manage separately two different kinds of storage. As mentioned, flash storage is leveraged judiciously. And Arjun, as you're looking at some of your customer base out there, and what are some of the challenges they're seeing around consuming flash in the data center? Are they having complexity challenges and cost challenges? What do you see out there in the customer base?
Yeah, I think one interesting thing there is all flash sounds great and everything, and it does give you higher performance, but you got to pay for that performance. And so there's a lot of benefit in hybrid architectures where you can use the flash for performance, but take advantage of spinning disk for capacity and get that trade-off between performance and cost.
Absolutely, and that's one of I think that's I see hybrid scenarios where we combine flash and spinning disk into the same units as really a sweet spot for today's storage environments. And as was just mentioned, we don't really have to go all flash. In fact, there are some use cases that might demand all flash, but they're few and far between, especially as you look at what we can do with today's hybrid storage systems, again, where we combine flash and spinning disk. All flash can be expensive, and you don't get the capacity generally that you're going to get from spinning disk. So having the ability to use both in the same system in a way that's very transparent to the administrator can be a pretty powerful combination. And I think the key to the economic side of the house is the ability to leverage commodity hardware. And really, this gives us some choice, depending on the solution. We start to get some choice about what kind of hardware we're going to use for our storage and our servers because we combine those in a hyper-converged infrastructure. Again, we basically eliminate the SAN and we take all of that previously SAN-trapped storage and we distribute it among the various nodes in a hyper-converged cluster. And we combine those nodes together with software. And we run everything on commodity hardware. And that doesn't mean it's junk. It just means that it's relatively interchangeable. The hardware becomes less of a critical point. We have to have the hardware, but we can use hardware from any vendor. Now, we're going to talk about one challenge to that shortly. What we get as an end result is an overall simplification of the administrative experience. And one of the things we've tried to do in IT for years is make things easier for the users, and that's what the users demand. Well, there comes a point at which we have to do the same thing for ourselves. And if we don't do that, we end up with more and more complexity and less ability to really meet changing needs of the business. And that's going to be sort of the death knell over time. We can't necessarily continue to add staff all the time as we're adding more infrastructure. And what this allows us to do is to begin to think about ways we can redistribute staffing resources. This doesn't mean that we're going to fire everybody that used to manage storage. What it means, though, is we're going to change those jobs around a little bit so that they're managing a wider swath of infrastructure, but not having to go as deep into the overall management experience with those individual resource silos. Arjun, is that kind of what you see in some of the Maxta client base when you're out there talking to people? Is this kind of what's starting to happen as people want to go wider and a little bit less deep?
Yeah, exactly. And I think that's one of the big benefits of hyperconvergence. Many hyperconverged solutions is being built for the virtual environment and really simplifying the IT management process there.
What we get is the ability to decouple staff growth from infrastructure growth. And that's really one of the keys to ongoing and sustainable economics as part of IT. One of the phrases that I hate more than anything in the world is do more with less. However, it's a reality, and it's something that we're being expected to do a little bit more and more of over time in IT, is do more with less. That means that as we add more services to the data center, as we have to add more systems, we can't necessarily have to hire the IT staff necessary to manage those in a traditional way. There can't be a one-to-one relationship between infrastructure growth and staff growth. And that's really one of the key things the hyperconverged infrastructure can start to help us overcome, is to change that ratio a bit so that we're able to grow our infrastructure without having to grow our staff as much. And we've got our first question, and Arjun, I think this is a good one for you to take. What is the difference between software-defined and hyperconverged infrastructure?
Yeah, definitely. So, the key difference there when we're talking software-defined versus hyperconverged. Hyperconverged is really the concept of bringing your storage into your compute node. So you have these converged compute storage nodes, whereas software-defined could apply to kind of, putting a software-defined layer on top of your existing storage array. And so that's where, hyperconverged really gives you that benefit of bringing everything into that converged compute storage node.
And thank you for that question. We always, again, use the Q&A control panel liberally, and we will answer all the questions that we can in this presentation. So, what are some of the challenges that around hyperconverged? We know that there's a lot of good things about hyperconverged infrastructure, but as we're looking at some of the initial adopters, early adopters for this technology, there's been some challenges that have been identified. First of all is the scale up versus scale out question. We're going to expand on that in just a minute. There's also a question of software versus hardware. Which approach is best? Do I buy an appliance or do I buy a software solution and then install it myself? We're going to talk about that in just a second as well. And the third question actually aligns with a question we just got in the Q&A panel, which is around hypervisor choice. So Harold, if you can hold on for just a second, I promise we'll answer your question as a part of this presentation. Let's talk scalability. First of all, what does the word scale really mean? And I think this is a key question. Does it really mean being able to grow really big, or does it mean being able to grow in a way that makes sense for my organization? And I think it means being able to grow in a way that makes sense. When we hear the word scale, though, we often think big. We often hear things like Google being thrown around, Facebook. You know, they grow at scale. Well, even the smallest of the SMB has to be able to grow in some way that makes sense for the organization. So I think scale really means being able to grow to the size that I need in increments that make sense for my organization. And that's very tailored depending on the kind of organization you're in. In fact, two organizations in the exact same market, in the exact same line of business, might have wildly different scaling needs because they do business differently. And that means each one of them has to have solutions available to them that make sense for their business. One of the things we're seeing with a lot of hyper-converged infrastructure vendors on the market today is that they sell basically appliances. And that's great. And there's a market for that. There's people that want to be able to sort of have that set it and forget it way of looking at the data center. They'll buy a bunch of appliances and they'll scale. And in those infrastructure scenarios, they're scaling linearly with all their resources. It's often called linear scalability. And so we're actually, every time we add an appliance, we're adding RAM, compute, network, and basically whatever else to the cluster that we already have. Now, the challenge there is we may not always have to be able to scale all resources at the same time. We might have to scale resources in ways that are decoupled from one another. So we might want to add more storage on a new node than more RAM. Or we may want to just add more storage to an existing node that we already have. With an appliance-based hyperconverged infrastructure solution, that's not always possible. You can't open it up, add more storage, add more RAM, or whatever you need to have. It's basically a closed environment that you have to basically buy another appliance to be able to get more resources. What needs to happen for others? Well, again, that's fine for some people. For other people, they want more control over the individual resources. So there needs to be a solution out there that gives them the choice to be able to grow an individual node or to add a new node when it makes sense. And that's what we're going to be talking about today. Again, when we start looking at hyperconverged infrastructure, they lack the ability to scale individually, individual resources. But again, you have different needs than the company down the street. So you may want to add more RAM to a particular node that may not always be possible with every hyperconverged infrastructure on the planet. And I'm looking at the questions. Here's a good question, Arjun. I think this is an interesting one because it focuses a little bit on the storage side of things. Okay. How does a hyperconverged model affect tiered storage solutions?
Well, I think there's, hyperconverged can be applied to that kind of tiered storage where you can either, coexist in the environment, have hyperconverged provide you, tier 2 when your array is providing you tier 1, or even within, some hyperconverged solutions, you can actually allocate, you can pin VMs to your flash, and you can allocate those specific resources to those specific VMs as necessary.
And forgive me for the little font issue there, but let's take a look at a picture here. This is a traditional, or what we see as an appliance-based hyperconverged solution. You can see that all four of the appliances at the top are identical. As we needed to add more, we added more RAM, more storage, and more compute on each node. If we were to look at the resource needs in aggregate, the actual need would be 4 sticks of RAM, 3 sets of storage, and 5 processors. Now, again, it looks differently than that in the real world, but for our purposes here, that's sort of how to look at it. So instead, what if we could grow with a first appliance that gave us RAM, storage, and 2 processors. The same thing with the third appliance, but the fourth appliance gives us 2 RAMs, a storage, and a processor. So we can actually custom tailor the individual nodes to meet our actual resource needs. And then, instead of having to add additional appliances, what if we could just add more RAM and more storage to one of the appliances, and again, more RAM and even more storage to one of the other appliances? This gives us basically the ability to scale out. Now, scaling out is the ability to add more appliances and also scale up, which means we add more resources to the existing nodes that we already have in production. This gives us the most potential flexibility in our hyperconverged infrastructure scenario that allows us to grow in ways that make more sense for our organization and far more granularly than we might be able to do otherwise. Arjun, do you have any thoughts on this?
Well, I think this is one of the really big benefits that kind of Max as a company that we provide, where you have this ability to scale up and scale out, as Scott just mentioned. So you can really grow as you need. You don't need to buy additional resources because you're locked into that appliance. You can grow your memory or your storage or your CPU exactly as you need to fit your environment.
And we'll go on to our next slide here. Now, the other thing to think about when you're buying a hyperconverged infrastructure solution is the hardware. And you can buy pre-configured appliances that basically, as I mentioned before, give you the ability to just add more appliances as you go. But you can also get pre-configured scale, and you may not be buying underlying hardware that's from a preferred or an approved vendor. And for some, that's a pretty big deal. They want to buy a certain brand of servers. They don't want anything else in the data center, even the underlying hardware from a hyperconverged infrastructure solution. We also have software only. So basically, you buy the software and you install it on your own hardware. This provides you with additional levels of resource granularity because you basically custom configure individual nodes to meet your business needs. But the software solution is not always embraced as complete. So people look at it and they say, well, if I buy this, where's the simplicity? I've got to install everything myself. And there's an answer to that you're going to learn about in just a few minutes. The other challenge people have around some hyperconverged infrastructure solutions is hypervisor. And this is one of the questions that someone asked in the Q&A, which is basically what hypervisor is supported. Well, it really depends on which hyperconverged infrastructure solution you're going with. Some hyperconverged solutions support only vSphere, some support only KVM, some support only Hyper-V, some support combinations of the three, but it really depends on what you're looking at. And you're going to hear from Maxta in just a few minutes on what they support, and I think the answer will be a very pleasant one for you. vSphere does lead the pack, but it is expensive, and people are starting to look at that as an area to potentially cut costs. And people are also trying to decouple themselves from what they perceive as vendor lock-in with regard to the hypervisor. One of the things that I hear from people is that their dissatisfaction to a point with vSphere goes back to the early days of vSphere 5, when they introduced what became known as the VRAM tax. And people realized at that point that they were locked into something that they could change at any minute. And people have been looking for ways to try to decouple themselves a little bit from vSphere ever since. Now, that doesn't mean there's not a mass exodus going on, but there are some people looking for alternative hypervisors to be able to run in a hyperconverged scenario. Hyper-V and KVM are growing big time. We see them a lot in the market today, a lot more than we have in the past. Hyper-V especially is growing very quickly compared to other ones on the market, and KVM is growing very quickly, partially because of hyperconverged infrastructure. For these hypervisors, cost is a big deal. Hyper-V and KVM are both much less expensive than vSphere, and people like the economics around these two hypervisors. And lock-in is a factor as well. But we also see things like, especially in larger enterprises, OpenStack gaining steam as an alternative to the whole mess. And we're going to hear more about that later on. And with that, I'd like to turn it over to Arjun from Maxta to talk about what Maxta brings to the equation. And I will turn over control to you, Arjun.
All right, thanks, Scott. So yeah, I mean, I just really want to go. There we go. So just want to, really go over the main principles that Maxta brings to the table. And it's a lot of what Scott had discussed about, which is that we're really trying to maximize the promise of hyperconvergence. And we say that, there's 4 key points that we're following. One of those is flexibility. That's a big portion of what Scott was just talking about with any server, the hardware of your choice, any hypervisor, whether that be vSphere, KVM, etc. So, really this ability to pick the hardware that you want, to leverage your existing server vendors and maintain that relationship that you have. And, the next point is simplicity, which is a big concept across all hyperconverged deployments, which is that we really want to simplify IT, focus on managing VMs, not your storage. No more kind of, creating and managing LUNs and volumes. Just focus on managing your VMs with these VM-centric data servers, everything at VM level granularity. Now, scalability, which Scott had also discussed a little bit. Sorry.
We have a couple of people in the Q&A that are saying that there's pretty bad echo. Are you?
Okay.
I don't know if you're on a headset.
Let me. Is it? I'm using the computer audio. I can try to switch to the phone if that would be better.
Do you have a headset you could use? I'm not getting the echo, so it's hard for me.
Yeah, I don't have a headset with me right now. I can try to grab one really quickly and see. Let's see if that'll
Sure.
be better.
Yeah, we've gotten quite a few notes in here about that. So I'll answer a couple questions while we're waiting for Arjun to come back. One of the questions that was asked in the Q&A is, if you have storage integrated into your node, how do you protect the data if the node fails? One of the things that happens in most hyperconverged infrastructure solutions is there's replication going on, basically. So we're making copies of data on different nodes so that we can actually withstand the loss of a node. And we see this in most hyperconverged infrastructure solutions that are on the market. This ability to lose drives in a node, to lose entire nodes, and the system remains available for, in general, for everyone else to use. Now, obviously, if you're running virtual machines, you have to then take steps with things like DRS to bring workloads back up in other nodes. But that's one of the ways that we handle availability is through replication in a hyperconverged infrastructure scenario.
Hey, Scott.
And one of the other,
is this better?
is that better, everybody? Can somebody mention that in the Q&A? Can you talk a little bit, Arjun?
Yeah, sure. We can go through, start the presentation, see if there's any echo. How's it sounding now?
I heard it sounds good. We're good to go.
Okay, all right. Let's go ahead. Were you still answering up a question? I didn't mean to cut you off there.
Nope, I'm all done. We'll pick up the next question in just a few minutes.
Okay, all right. So continuing on here. So when we're talking scalability, it's a lot of what Scott had discussed, where it's this Lego-like ability to scale compute and storage independently, rather than being tied into an appliance, where you may be unnecessarily scaling compute when you only need additional storage, or vice versa. With Max's solution, you can go with these Lego-like building blocks and just scale your resources independently of each other. And of course, a big point is going to be, your increased savings, lower total cost of ownership. That's coming both from the hardware side, because you're not getting locked in, you're not getting any appliance overcharge, and then also from kind of just the simplified management, you're reducing your OpEx because everything is much easier to manage in your data store. And so yeah, just kind of an overview of some of the things Scott talked about already with limiting lock-in and how Maxta really fits into that solution. So we provide you with hypervisor of your choice, VMware, KVM, OpenStack. It really helps the data centers that are moving to this multi-hypervisor strategy, as Scott mentioned, where you want to future-proof your investment. You don't want to be locked into VMware in case they decide to change their price scheme, and you want to have that flexibility going forward where you can really go with, again, the vendor of your choice. Similarly, any server, right? Maxta provides you the ability to have the server of your choice. So you can retain that relationship in the support model of your existing server vendor, and you're just getting, our Maxta software on top of your choice of hardware. So you're not locked into a specific brand there. And again, the ability to scale compute and storage independently is a key tenet there to the Maxta Hyperconverged solution. So now, diving in a little bit into our architecture, one of the key points that we want to focus on here is the hypervisor agnostic architecture. And so what we're really saying there is our management framework and our core platform, which consists of the Maxta file system and object manager, are built hypervisor agnostic. So those two can be applied to, currently vSphere KVM, they can be applied to Hyper-V and Zen. And then on top of that layer, what we've built are these hypervisor-specific integration Maxta agents that plug directly into, ESX and vCenter, KVM, and OpenStack. And then additionally, on top of that, we've built just, a web for management purposes, what we call our MxInsight UI, which can also be integrated as a plugin into the vSphere web client. And the great thing there is the MxInsight UI is actually universal across all of these hypervisors, where when you log in to that management portal and the dashboard that you see, which I'll show you a little bit later, but that dashboard is the same whether you're using ESX, KVM, or OpenStack as your back-end hypervisor there. So now kind of a real deep dive into the nuts and bolts of our architecture specifically and how it looks. So what you're getting here is, you're looking at kind of just the minimum 3-node configuration where each of these, blue boxes represents one of the server of your choice, right? And so what you'll see is that when you kick off our installer, we install MxSP, which is our, our bread and butter, our Maxta storage platform. That's the software that gets installed on each server in your cluster. And, in a VMware environment, for example, that's going to be a VM. For KVM, we'll be running as a process. And so, these VMs are kind of communicating to each other across your shared network. And that could be, 1 gig or 10 gig Ethernet, dedicated or shared. And what they're doing is they're kind of aggregating these resources across your storage pool. So we're taking the SSDs and some of the in-memory cache from that Maxta VM to deliver you the high performance that Scott had talked about, where we're using that kind of, hybrid configuration to give you the tiering where you're getting the performance from flash, your reads and writes are coming from the read and write cache on flash, and then we're destaging data to your spinning disk to give you the capacity. And you're getting this real balance of performance and cost, where you're getting the performance from flash, but you're not spending more than you need to on flash, and you're getting your cost savings via the capacity coming from your spinning disk. And so, yeah, we present to you basically this Maxta global namespace, which, again, in a VMware environment will look like an NFS data store. For KVM, it's just going to present itself as local storage on each of the nodes running in your cluster. And you just treat it as any other data store that you normally would in your environment. And it's going to give you all the functionalities you expect, the snapshots and clones, the high availability, which we'll get into again later. And the key here, again, when we're talking about the hypervisor layer, currently we support VMware and KVM. And as I showed you, our architecture is hypervisor agnostic. So, Hyper-V will be coming shortly, and as the need arises, we will be developing support for all of these solutions. And then another key here in terms of kind of the flexibility and choice is that we have support for all storage devices. So when we're looking at the storage layer, your SSDs could be NVMe, PCIe, SATA or SAS, depending on your requirements. And again, your spinning disk could be as simple as your 7.2K RPM SATA, or they could be higher performing SAS if you're really concerned about the performance on those cache misses. And so, yeah, just to kind of, sum up this architecture a little bit more. So what you're really seeing is the HDDs, and, that's what's going to be your Maxta data store. The SSDs are also being consumed by Maxta for flash performance. Your CPU and memory is being consumed by the hypervisor to give you that shared, resource pool that you're so used to seeing. And then you have your MxSP, Maxta storage platform, our secret sauce, communicating with each other over your Ethernet and presenting to you this global namespace. And then you have your VMs writing to that global namespace and maintaining, replica copies to give you high availability. So we make a copy of your data on each, at least one copy of your data across another node in the cluster. And we also do wide striping so that you're getting the performance across all the nodes and disks in the cluster. So it's kind of like, what we refer to almost as a network RAID, where your data is copied across nodes and striped across the disks and nodes in the cluster. So now, what does this architecture really give you in terms of features and functionality? So here you kind of get an overview of everything that we have. So data integrity, we're giving checksum at both when data goes across the network and when it's stored locally on the disk. So you can ensure that you have that integrity. And as I mentioned, we maintain a replica copy of your data on another node in the cluster. So if there is any data integrity issue detected, we can easily repair and recover your environment with zero downtime or data loss by using that replica copy that's available on another node in the data center. Simplicity, again, this is a big thing for hyperconverged solutions in general, which is a strong focus on managing VMs, not storage. So no more creating LUNs, no more setting up iSCSI networking. Just want to be, a virtual administrator, a virtual data center administrator. So just managing your VMs, taking snapshots at a VM level, not unnecessarily, copying LUNs when you're trying to create a clone. Everything, again, on a VM-centric, VM-level granularity. Data protection, the Maxta storage platform really gives you this ability to take an unlimited number of zero-copy snapshots and clones. And these snapshots and clones are both time, performance, and capacity efficient. So what we're saying there is that time efficiency means that you kind of take these snapshots or clones, and they're created instantaneously. Performance efficiency means that you can create an unlimited number of snapshots or clones and have zero performance degradation across your environment. And so that way you can create, as many of these point-in-time backups as you want and not see a performance impact on your environment like you would with some other solutions. And again, capacity efficiency, because we're doing everything at a VM level and because we're just, really just kind of creating a pointer to your data rather than physically copying data when we do clones and snapshots, you're getting, you're using zero capacity when you create a snapshot or a clone. So again, it's just a big benefit that comes from that Maxta storage platform. High availability, we're really focused on having zero downtime and zero data loss in failure scenarios. So as I mentioned, we make a minimum of one copy of your data across the cluster, but that's even a configurable parameter on a per VM basis where you can have certain VMs that you really cannot sustain, any downtime to. So you can create multiple copies of that VM, and Maxta will maintain those replica copies across nodes or even sites, depending on how you configure your data center. And we'll ensure that you can survive up to 2 node failures or 2 disk failures or more, depending on how you configure your environment. Capacity optimization, Maxta provides you with thin provisioning, those time, performance, and capacity efficient snapshots and clones, inline compression, and inline deduplication. So even though we're making these copies of your data to give you that high availability, because of our capacity optimization techniques, you're still able to regain 2 to 4x in capacity savings just based off of those algorithms that we use. And then performance, again, as Scott had mentioned, and as I've discussed too, we're giving you that benefit of both the performance and the cost benefit, where we're using your SSD and your flash media as that caching layer and taking advantage of the spinning disk, the cheaper spinning disk for capacity. So you're really getting the best of both worlds there. So now one thing I want to focus a little bit on here is kind of this idea that Scott touched on a little bit where, let me go back a couple slides here. The idea that we are a software-defined solution, but Scott also mentioned that, some people want the simplicity of an appliance. So what we're really doing at Maxta is we were born as a software-defined storage company, as a software-defined hyper-converged storage company, I should say. Software-centric, so software-only solution, the Maxta storage platform that can, gives you that flexibility to do it yourself with your choice in hardware, and you can even, install it on your existing infrastructure. You don't need to upgrade everything. And that software, as I just mentioned, is full featured with all the enterprise-class data services that you're used to getting from your traditional storage array. And we also have a strong relationship with Intel as a development partner and as an investor in our company, where we can support the latest and greatest technologies from day zero, whether that be NVMe or having access to the Grantley V3 processor before it was released to the public, and being able to support that from day zero. But now, as Scott had mentioned, what if this kind of flexibility and choice is almost too much, right? You don't want to really have to think so hard about how you should build your environment. Well, that's where we have the Max Deploy solution, which again, Max Deploy is just going to be built on top of MxSP, leveraging the same exact software, but it's providing you with this reference architecture for a hyper-converged infrastructure. So it's a pre-configured and validated server configuration that's just running Maxa storage. And as I'll show you on an upcoming slide, basically what it is it's just, it's a configuration tool to help you through the deployment process. And it's just, in the end, it's just your Cisco server, your HP, your Dell, whichever, server vendor of your choice that's being either delivered by a Maxa partner or even by your own partner, your own preferred vendor. We're just working with you to give you the best configuration for your environment. So really, Max Deploy is building on top of MxSP and giving you this peace of mind with the known interoperability, the predictability of performance, and again, the ease of ordering. So you're getting your choice of software, your choice of hardware, where you can go with the server vendor of your choice, you can go with the storage devices of your choice, you can go with the hypervisor of your choice, but you're getting some guidance so that there's not so much complexity in this ordering process. And so as I was discussing here, this hardware agnostic implementation, right, where we have this Max Deploy kind of configuration tool on our website that gives you these validated configurations based on your use case, based on the server vendor that you want, the capacity, or the number of virtual desktops, and we can provide you with that suggested server configuration. And then when you decide to go ahead and order from us, we can work with one of your partners so that you maintain your existing relationship, or we can work with our own partners to get you the hardware that you need for your environment. And then just kind of want to highlight a few of these really nice features that we have in our platform. Oh, sorry, I jumped ahead again. It's getting double clicks here. So we have this MxInsight user interface, which is really our next generation UI, and that's what I was talking about, where it's a common management framework for whether that be for VMware, for KVM, or for OpenStack. So if you're running KVM and you don't really have a hypervisor manager, as such as a vCenter or an OpenStack, you can actually come into our UI and you can do tasks like VM creation. You can check on our dashboard and see how much capacity usage, what your latency, IOPS, and throughput statistics are looking like on your data center. And again, this UI is available whether you're deployed on VMware, KVM, or OpenStack. So it really just gives you, a simple kind of way to access our information. And it's also for VMware, for example, it's integrated into the vSphere web client as a plugin. So you can be managing your vSphere environment and your storage environment from that single pane of glass. Similarly, for OpenStack, we've integrated with their Cinder and Nova plugins, so that when you do a snapshot or a clone or create a volume or create an instance, it will be directed through the Maxa data store or through the Maxa storage, and you'll get all those benefits that we've talked about with those enterprise class kind of features and functionality. And again, on the UI, one of the big things here is you're getting historical and real-time statistics when it comes to both performance and capacity, and you're getting those statistics on either a cluster level, which is what we're showing here on our dashboard, or you can dig down to kind of a per node, per server basis, and you can even go as low as VM level and virtual disk level granularity to really see what's going on, whether it be cache hits and misses, whether it be latency, IOPS. You can really get a good view and understand exactly what's happening in your environment at any point in time. Now, another thing we really want to provide is improved serviceability. And so that means that, you shouldn't have to worry about, I don't know where this double click keeps coming from. Sorry, how do I get back here? Well, now you guys know what's coming, so. Anyway, so this improved serviceability, what we've developed here is this MX Cloud Connect, where it's basically, a maxed cloud where we're sending alerts and events. We're sending some data to be, provide you with data analytics. We're giving you proactive support. So if there's alert that is generated on your cluster, so as you can see here, on the left side, kind of your deployment of Maxa, if there's an alert if you're running out of capacity, that alert will be sent up to the Maxta cloud, and our technical support team will be able to proactively say, hey, customer, did you realize that you're running out of capacity? Can we help you order some more disks, and things like that, just to make sure that you don't hit an issue and then have to kind of retroactively address it. And again, the data analytics will be a big thing where we can really look at your usage statistics and see kind of what can be done to best configure your environment for your use case. And then again, just kind of the flexibility in terms of the use cases that Maxta supports. So we can be, primary storage for your business applications. We can be the solution in a remote branch office, whether that be in your headquarters or in the branch offices themselves. You can have Maxta storage running on that, little 3-node configuration that you have in your office in Timbuktu. We can be the solution for your VDI environment. We can be a DR storage site, whether that be the primary site or the secondary site that's being replicated to. We can also be a solution for your test and development. Again, with those great cloning and snapshotting technology, it's very easy to kind of provide the necessary infrastructure for that test dev environment and not unnecessarily use up capacity. And again, also not suffer any performance degradation with those Maxta clones and Maxta snapshots. Additionally, Maxta has been a great solution for managed service providers because they're getting that flexibility and that choice, where an MSP can really say, oh, I have some customers who want OpenStack, I have some customers who want VMware, I have some customers who want to be backed by Cisco, but I also have a great relationship with HP or Dell. So you can really get that flexibility and choice throughout your environment and have a great hyper-converged solution for your data center. So now finally, just kind of an overview of everything we've talked about, right, and everything that Scott has talked about to a degree. So hyper-convergence and Maxta's specific solution, we really want to maximize your simplicity. So we're converging your compute and storage, getting rid of that traditional array, getting rid of managing, multiple interfaces, reducing your, you don't have to have that space in your data center for an array. You don't have to have all the networking going back and forth between the array and servers. We're working on your standard commodity servers, whether that be, your existing infrastructure or new servers that you choose to order from the vendor of your choice, where you can maintain that relationship. And just even from a management perspective, if you're familiar with Dell's kind of ILO interface, you can stick with that interface with the Maxta solution because we give you the server of your choice. Maximizing efficiency, again, tied into simplicity there, with being able to manage VMs and not storage. And the scalability, that ability to scale compute and storage independently, rather than having to buy a full appliance and not necessarily, and over-provisioning in that case, not meeting your exact needs as it's defined within your data center. And of course, providing you with all the enterprise-level features and functionality that you expect from your storage solution. Now, maximizing flexibility, again, this has kind of been the central point that we've been going around and around about, but any server, any hypervisor, and the ability to scale up and scale out as you choose to fit your data center needs. And all this kind of comes together to really maximize your saving, whether that be CapEx or OpEx, right? We're lowering your hardware costs, giving you the ability to go with the vendor of your choice, and not charging you a markup like some of our competitors do who are selling you appliances where just because they have their name on the bezel, they're going to charge you 2x the price. We're lowering your infrastructure costs compared to the traditional storage array, right? You no longer have your big arrays kind of sitting in that data center together. We're reducing your cooling costs. We're reducing the space, the power consumption. So giving you that CapEx benefit. And then, of course, from an OpEx perspective, managing everything from a single pane of glass, kind of giving you the ability to manage your storage at a VM level with all the VM level policies, the VM-centric data store, just all of this kind of combining together to make your life easier and giving you that ability to escape the lock-in that is kind of permeating throughout the data center these days. And so I think that's all we have. I wasn't able to see the questions on here, Scott. I don't know if you want to kind of run through a few of them.
I thought we'd go through them right now. One of the questions that came up was about what kind of internetworking do you need between the nodes?
Yeah, definitely. So our Ethernet requirement is just either 1 gig or 10 gig dedicated or shared network. So it's pretty flexible. We recommend a 10 gig dedicated, but depending on your networking needs, you can be, as little as a 1 gig shared network. And what we really do there is we create a private storage network for Maxta for that storage traffic, and then you already have your management network that's been set up for your virtual environment, for your VMs or for your instances.
Another question we have is about encryption. Do you encrypt data while it's at rest in the cluster?
We do not do encryption on our own, but we have tested and validated solutions with self-encrypting drives where you can just install Maxta on top of those SEDs and get an encrypted solution that way.
When we talk about MxInsight, does it go down to the application level, or does it stay at the hypervisor hardware level?
So the level of granularity you get there is going to be at kind of a virtual disk, VM, node, or cluster level. So
Now,
it stays at the hardware and hypervisor level.
The next question I suspect is it's going to be it depends, but it's what are the expected IOPS? And I imagine that would depend on the hardware configuration that the customer chooses to use.
Exactly. That's dependent on the hardware configuration, how much SSD and what type you decide to load, and also on the workload.
Okay. We also have a comment from someone that says, "I'm not sure when I've attended a more thorough presentation." So thank you, Arjun, for being for the thorough analysis or the in-depth look at the Maxta solution. I appreciate that.
Yeah, thank you.
And well, the other question I think you answered was, does the software provide dedupe and compression on the data? And the answer is yes.
Yes, that's correct. Inline compression and inline dedupe.
Is the MxSP hypervisor version independent? So now hypervisor independent, but what about version? Like, it sounds like you're not going to support ESX3. I mean, so what are the?
That's correct. So
currently
we're our support tree is up to ESX 5.1.
Okay. Excellent.
And on the cable, yeah.
How do you do regular daily backup without affecting the application? So give us a little bit of deeper insight on data protection.
On the data protection, yeah. So basically, when you're talking about the snapshots and clones, we even have an automated policy for snapshots where you can set through our, it's a very simple UI. You can specify a VM, provide a snapshot policy name. We call it kind of a snapshot policy. So pick a VM or multiple VMs, create a name, and then set a schedule to say, okay, I want to take snapshots of this VM from Monday through Wednesday, or sorry, Monday through Friday. I don't know why you can only do Monday through Wednesday. Monday through Friday, let's say, and let's say at off hours, so from 10 p.m. to 8 a.m. And I want to take a snapshot every 2 hours or just one only. And then we also have the snapshot retention built into that policy where you can customize. Okay, I want to keep 100 snapshots at a time, or I want to keep snapshots for a week at a time. All these are customizable parameters so that you can really specify the number of snapshots you want to take, the VMs you want to take snapshots of, and how long you want to retain those snapshots for. And you can easily go back and forth. Yeah.
I think this is an important question, but it's not one that's always easy to answer. Tell us about how the product is licensed and where pricing starts.
So we're licensed based on capacity and number of cores. And if you want to find out pricing, I suggest you visit our website or give us a call, and we'll set up a demo for you.
That's even better. And we can see if there's anything else. I think this question follows on to another one that was asked. It's about backup again. It's how do you back up without slowing down the application because the data has to come from the same place?
How do we back up without slowing the
without
application?
Performance impact, basically?
Right. So the point there is that we've had a customer who challenged us on this also, and they basically went ahead and created 4,000 or 5,000 snapshots of a VM on our data store and continued running their tests and didn't see any performance degradation. Again, this is because we're just making kind of metadata pointers to the existing data, to the existing VM.
Great. I think that's all the questions we have time for. We will try to address some of those in a follow-up, but we will also send out a copy of the presentation to all attendees. That was another question that was asked. And we also have a gift card that we need to give out, a $300 Amazon gift card. And today's winner is Marlon Wilkes. So Marlon, we'll be reaching out to you to provide you with a link to get your Amazon gift card. And Everybody, thank you very much for watching. Arjun, thank you for your excellent presentation. That was a great overview of Maxta.
Yeah, thanks for having me, Scott.
And this is Scott Lowe with Actual Tech Media. Thank you very much, and we look forward to seeing you on a future event.